Welcome to Beyond the Lens, where history comes alive, and every documentary takes you deeper than ever before. History isn't just written in books. It's carved into ancient ruins, hidden beneath the oceans. For breathtaking this is a journey beyond the lens.
Look at Dubai in the late 1990s. It was a modest trading port, a city of low-rise wind towers and fishing boats, getting by on small-scale commerce and pearl diving. The city's leaders faced a hard deadline. Unlike its neighbors, Dubai had relatively small oil reserves. That underground wealth was drying up, and once it was gone, the local economy would go with it. To survive, the government engineered a massive economic pivot. They drafted plans to turn this stretch of sand into a global hub for tourism, finance, and high-end real estate. But convincing international investors to pour capital into a desert required a physical statement. The mandate was clear: build a structure so massive it would force the entire world to pay attention. The Burj Khalifa was born from pure economic necessity. To secure the city's future, Dubai had to break the ceiling of what was structurally possible. The task fell to developer Amar Properties and architect Adrian Smith. They drafted a blueprint for a tower reaching an immense 828 meters into the sky. To prevent international competitors from trying to outbuild them before completion, the final height was kept strictly confidential. Even the crews laying the early foundation didn't know exactly how high they were going. This ambition immediately hit a physical paradox. They were attempting to erect the heaviest, tallest structure in human history on ground that naturally resists vertical construction. Reaching a half-mile upward meant engineers first had to invent ways to defeat three severe environmental threats: loose sand, extreme heat, and violent high-altitude winds. The first major obstacle was the ground itself. You can't put a traditional wide foundation on Dubai's subterranean layer because it is composed entirely of loose sand and fragile rock. This illustrates the solution: relying on deep friction. Engineers bypassed the surface entirely, drilling 192 reinforced concrete piles straight down. Each of these columns extends roughly 50 meters deep, creating enough surface friction against the surrounding sand to hold fast. It took 45,000 cubic meters of concrete to complete this subterranean grid, forming a massive anchor weighing 110,000 tons. Without anchoring this immense mass using deep friction physics, the entire multi-billion-dollar project would literally sink into the desert before reaching the first floor. Once the foundation was secure, construction moved above ground, where the crew collided with the second major threat: the blistering desert sun. High ambient temperatures cause poured concrete to cure too rapidly. When moisture evaporates too fast, the material shrinks and cracks across the surface. A compromised, cracked foundation trying to support a half-mile-high skyscraper is a catastrophic failure waiting to happen. The logistical fix was to completely abandon daytime pouring. The crews shifted their schedule to pump concrete exclusively during the night shift when the air was cooler. But they also needed a chemical fix. Workers pumped chilled water and raw ice directly into the concrete mix to artificially suppress the core temperature while it traveled up the pipes. By manually manipulating the core temperature of their materials, the engineering team forced a hostile, uncontrollable climate to conform to their strict construction schedule. Pushing into the upper atmosphere required special self-climbing cranes attached directly to the building. As each new floor was completed, the cranes hoisted themselves higher. This extreme altitude exposed the tower to severe coastal winds, an invisible force capable of causing massive structural swaying in standard skyscrapers. To solve this, the architects looked to biology. They drew inspiration from a regional plant called the Hymenopilus flower. This animated blueprint translates that natural petal geometry into a Y-shaped footprint for physical stability. As the tower rises, the walls step back in a staggered spiral pattern. This uneven surface actively confuses the wind, breaking the currents apart chaotically. By abandoning traditional boxy engineering for natural biomimicry, the designers outsmarted atmospheric physics. They ensured the tower wouldn't tear itself apart in the sky. Pushing the structure upward required a staggering amount of human effort. An army of 12,000 international workers operated around the clock to maintain the momentum. By 2007, the incomplete skeleton hit a major milestone. it officially surpassed the height of Taiwan's Taipei 101, taking the crown from the previous record holder. The massive construction site dominated the landscape, rising out of the dust and proving that Dubai's audacious vision was becoming a physical reality. The physical engineering was working perfectly, but a completely invisible threat was about to strike. The economic foundation of the entire project was suddenly failing. This chart shows the rapid collapse of global financial markets. Just as the tower claimed the world height record, the 2007 financial crisis struck, sending asset values violently into the red. The engineers had successfully defeated the sand, the heat, and the sky. But the true threat to Dubai's future was the sudden evaporation of the international capital required to finish the beacon. To see how this devastating financial crash nearly killed the world's tallest building before it ever opened, click over to Part 2. Look at this high-angle aerial view of a massive construction site in 2007. This vast, sandy expanse in Dubai was where developers began building a megastructure, originally called Burj Dubai. Floor after floor, the tower climbed relentlessly upward, designed to anchor a multi-billion-dollar district and signal Dubai's intent to compete with the world's established financial hubs. Then, the 2008 global financial crash hit. Property prices across the world plummeted, and billions of dollars in global real estate investments simply evaporated overnight. The impact on the ground in Dubai was immediate. With construction cranes resting over unfinished, exposed concrete, there was a very real possibility that this half-built structure would permanently sit abandoned in the desert. To finish the world's tallest building, engineers and developers would have to figure out how to survive a collapsing global economy and conquer one of the planet's harshest natural climates at the exact same time. Panic quickly set in to Dubai's property market, driven by rapidly spreading rumors that work on the massive tower was going to cease completely. The rescue came in the form of crucial financial intervention from neighboring Abu Dhabi. They stepped in and injected the necessary capital to stabilize Dubai's crashing economy. That external bailout guaranteed the necessary funds to finish the tower, transforming it from a highly vulnerable financial liability into a regional symbol of economic resilience. With the money secured, the focus shifted entirely to the physical reality of building it. The engineering teams faced two severe natural enemies: extreme desert heat and punishing wind currents at high altitudes. To protect the structure, workers installed thousands of specially engineered exterior glass panels. These were mathematically designed to deflect the powerful high-altitude winds and reflect intense sunlight away from the interior rooms. Getting people up and down a structure of this scale presented its own logistical nightmare, requiring the installation of customized high-speed elevators capable of traveling hundreds of meters in less than a minute. At the very top, crews executed a highly dangerous, high-altitude assembly of the final steel spire, locking the peak of the tower into place. This chart shows exactly how the Burj Khalifa compares to previous record-holding skyscrapers. The developers made a strategic decision to keep its final height of 828 meters a closely guarded secret during construction, guaranteeing no rival projects could announce a taller building before them. To understand the internal climate control, we can look at this simplified cross-section schematic of the tower's HVAC system. Pumping air conditioning through a building this massive creates a huge volume of condensation, which is actively gathered at specific collection points, highlighted here. Instead of letting that wastewater drain away, it travels from those high-altitude points down through the internal piping and flows out into the ground-level gardens to irrigate the surrounding desert landscaping. These specific engineering adaptations solved the vertical logistics and tamed the hostile desert climate, turning an impossible structure into a functional environment. On January 4, 2010, the project celebrated its success with a massive public inauguration, framed by a spectacular white and gold fireworks display over the skyline. During the ceremony, the public received a surprise announcement. The iconic structure they all knew as Burj Dubai was getting a permanent name change. It was officially renamed the Burj Khalifa. This was a deliberate act of honor and gratitude directed at Sheikh Khalifa bin Zayed Al Nahyan for the crucial role his capital played in the economic rescue. That sudden renaming permanently embedded the political and economic history of the 2008 crisis into the actual identity of the structure. Inside, the completed tower operates as a self-contained ecosystem, holding premium office spaces, fine dining restaurants, and luxury residences. It also houses the highly exclusive Armani Hotel Dubai, cementing the building's premium status with interiors personally designed by fashion icon Giorgio Armani. More than a decade after its completion, the building holds a long list of world records, including the highest occupied floor and the tallest freestanding structure on Earth. Standing fully illuminated against the night sky, the tower remains a permanent record of the moment. Human imagination outlasted a global crash and tamed the planet's harshest environment.